everyone. Thanks for joining. I'm Matthew Brender. I'm the developer advocate on the software-defined infrastructure team and one of the maintainers of Snap. It's an open telemetry framework which has grown in adoption quite a lot, and as of this conference is supported in production by Grafana Labs, which is pretty amazing. I'll be tag teaming this talk with Joel Cooklin, who's the team lead of the architecture of Snap, and he'll dig into the plugin architecture behind it. So the project's goal is pretty simple. It's just to collect, process, and publish telemetry, all the different metrics throughout the data center, and unify that behind a single API so that it's more attuned to your automation systems, so that you can query it and really do so in a smooth way. When we were looking at existing tools, we didn't see the same patterns that our data center users needed from an Intel perspective in order to give them access to the silicon metrics that we have available to them, but then to have them act on it in a systematic and automated way. And when I talk about telemetry, it comes to being it's kind of a confusing term. It's a little nuanced. So everyone has their own little perspective of it. Most people find it kind of boring. My parents think it's some band from the 80s. Society immediately thinks of NASA, which I think is pretty universal, that when you say telemetry, you think you're sending a rocket to space. Bosses tend to think of it as money, because data is the new gold or oil or whatever phrase you want to use these days. When I think of telemetry, I just think of a HUD, like a heads-up display as Iron Man. We're going to all be badass robot fighters. But then what telemetry actually is what we try to cover with Snap, which is just a small portion of the overall monitoring landscape. And since I'm at GrafanaCon and since Jason Dixon's a big deal in this community, I've been reading his book on graphite, and he actually talks about telemetry, and he refers to it as the collection of measurements, typically of remote instruments, for the purpose of monitoring. So really simple in scope. It's the collection of information from different sensors throughout your architecture and then publishing them to some endpoint. And right now in the industry, it's a choose your own adventure. There's a ton of different frameworks, and they're usually built into a larger system that includes a message queue and a persistence database and visualization and alerting, which are all pieces of the telemetry, all pieces of the monitoring landscape. But alone, it's kind of confusing when you mush it all together. They don't all solve the same problems. So taking a look at the landscape, there's, without a doubt, Collect-D is the de facto standard. It's been around for a while. It's written in C. It runs really fast. It has a ton of plugins. But it didn't have exactly what we needed when we were going to build Snap. A few other ones that you've heard about here. Telegraph is huge. It's part of the InfluxDB stack. And Diamond is a very common Python library that you use for instrumentation here that Joel will dig into more. There's plenty more, and then from your application point of view, since you need to query from the operating system and also get access to bare metal statistics, but you also want to instrument that at your application tier, you might have client libraries, and that's where Prometheus sent to. Many other tools have those libraries out there. So why did we build another tool then, if there are so many tool options? Well, I'm glad you asked. There are three reasons that I particularly find interesting, and I gave them little avatars to make them more memorable. One is composability, that monitoring stacks are not one size fit all. It's cheesy to say, but still true today, that you need to find the best in breed piece that fits for your architecture and fits into the overall goal. So I want to tell you a little about how Snap is composable. It's just that one small piece of it. It's declarative in the sense that you are explicitly saying what you want to collect and where you want to push it to, and extensible through the plugin architecture. In the monitoring landscape, it includes everything from persistence to the transformation of that data to the visualization, and ultimately you have to alert and have on-call and those kind of things that PagerDuty and other tools do. Grafana covers a lot of it these days, but also has graphite in its stack. Snap is a small piece of that overall. You won't find a message queue in there. We're using in-memory buffers and writing some logs to disk, but it's just a daemon model with plugins that load, and Joel will dig into that more. And then when you're dealing with plugins, the the composability of the plugin architecture, I think, is really cool. That the daemon runs on its own, and out of the box, it doesn't do much. It just gives you the ability of loading plugins to collect, process, and publish that data. You load tasks and through task manifests that will define what you want to collect and how you want to collect it. And we have, out of the box right now, I think it's 67 plugins to date that have a wide range of all the different publishers for different databases and message queues that are really common these days and are compatible with other tools that you use and collect telemetry, like we're snagging from cAdvisor, for example, which is another framework that is used in the Kubernetes community. What I really like, and what I'll demo in a second, is the declarative nature of it. When you load a plugin that has access to metrics, it doesn't just immediately start collecting those metrics on runtime. You can be as precise or as general through the task manifest as you'd like. So you define an interval, basically the granularity by which you want to collect your information, the specific metrics you want to collect, or a dynamic collection of those through a namespacing. You can actually put a star in there and collect a subcomponent of it, or you can be as precise or as general as you'd like that way. And then you say one or more endpoints that you want to publish to. And that's really nice that each one of these can be forked to multiple endpoints. But what I also really love is that you can run them simultaneously. So you don't have just a single task that defines all things you're collecting on each Snap daemon. You can think of them more strategically, like this application needs this visibility, this other application, I want to grab these stats, and you run them each separately so that when you're checking those into a version control or something like that, it's more one-to-one coverage and makes sense to you. So let's take a look at a couple of task manifests. Got a system up and running. SnapTell is the command line interface to Snap as of 1.0, and the package is called Telemetry. So I install this on, oops. Oh yeah, got that totally backwards. There you go. It's running. That was a lot of work to get it to show you that it's running. So SnapTell is the interface, the command line interface that I can use to communicate with it. If I list out the current plugins that we have, oops, and demo god, stop being cruel. Okay, we have. Let me. Looks kind of gross on this resolution because terminals. But we've got a few ls ops plugins. I'm loading by default a number of collectors. So we're able to collect from Apache, CPU statistics, psutil, which is common utility for operating system statistics, swap, and then a few publishers, so file and graphite. And then I also have a couple of these JSON files in here, Apache and Snap. So each of the files, the JSON files, are the task manifest. That's the declarative definition of what I want to collect and at what interval I want to collect it. And if we take a look at one of them, it tells you explicitly what I want. So we're running a schedule of regular intervals of 10 seconds. And we're collecting all of the following metrics, which are available through ProcFS, through a couple of the plugins that I've loaded up there. You'll see here that I've got a star so that we collect every CPU's statistics of, so for every CPU, gather the following statistics. And then at the very end, we say where we want to publish it to. And here we're saying publish to Graphite, got the server and the port ID. So look, by default, if I load something into OpSnap plugins on runtime, whether it's a task manifest or a plugin, it will load automatically and be running. So I've got a couple tasks running right now. This one I just showed you, and the Apache one. Apache one, you can see, is running at an interval of 5 seconds. So every 5 seconds, we're grabbing this information from the Apache service. What is really cool is that I don't just publish to the Graphite endpoint here, I publish to a file as well. So I don't have to just have one endpoint, and I can change this if ultimately like the whatever database you're using now might not be the database you're using in a week or a month from now. So you can update this task manifest and keep running it. And then I've got a third one I'm going to load that's got a different interval. I'm going to pop that down to 1 second actually so that it loads real quickly for us. And this grabs a bunch of information from the file system, inode counts and device counters, and also publishes it to Graphite. So let's load that new task. Oh, got an error on loading the task because it's looking for metrics that we don't have the ability to collect yet. The DF plugin for Snap gives you access to inode counters in the space that we need here, so we need to load a new plugin. And I've downloaded our plugins to a folder here. There's a ton. Right now we package them. We build plugins and give you the download links on our web page and also under the release tabs on GitHub. So I ran a script to download all those for me, and we'll load the DF one. So now that that plugin's loaded, we'll be able to create that task. Now with the task running, a really cool feature of this is that I can also watch the task live to make sure the telemetry is actually gathering it. So again, excuse the layout of this, but you can see that the last time I'm getting the statistic and what the statistic value is. And then I've got a couple pretty graphs where it's over here. I was playing around with Grafana 4.0, and I've got a ton of noisy alerts being sent to me on Slack. But you can see this has been running for a while, different network statistics, and I just loaded the disk free space one as well. And we're grabbing all these statistics from Snap, pushing it to Graphite into Grafana. And if I need new statistics, I would just need to create a new task manifest and define what I want to collect, at what interval I want to collect it, and then publish that without interrupting the current things that I'm collecting, the current plugins I'm using. It's all non-blocking from each other, which is a really nice set of functionality for the real world that includes a lot of variability. Uh-oh, did I exit my PowerPoint? Where is that? There it is. Cool. And the other part about Snap that I think has really grown its adoption is the extensibility. The basic model has the idea of collecting from different layers of your architecture, processing them through filters or decorating the information with further tagging based on other variables in your data center, and then publishing them to n number of endpoints. You can fork them, you can throw them into a database, you can pop them into a message queue, you can extend it into a new tool that you're working on. So 3 cases that I think are really impressive. The team from Staples has created, I think, up to like 8 different plugins now to collect information. So they're monitoring their own monitoring stacks from running Mongo and Couchbase. They've got collectors for those, and then they publish it to BlueFlood, which is an interface for Cassandra, and then also to Couchbase. And that's all available. Their code is available alongside ours in what we call the plugin catalog, just a list of all available ones. Been really excited to see Netflix pick up Snap as well. They were doing a POC where they're looking for a new monitoring stack for their Docker configuration. So they picked up our Docker collector, which queries the Docker API, and they're using that as a way to publish it into Atlas, which is their time series system as part of the Netflix stack. And they have a publisher available for Atlas if you're using that in production. And the last one, Grafana Labs. Grafana Labs has a POC plugin of Snap where instead of doing that manual command line to create a task and to watch tasks, you can do that right in Grafana out of the box with the plugin. So a few different cases of grabbing our API-driven technology and quickly extending it to use cases that they needed. And that's what I think is really impressive about being part of the open source community here. From here, I'm going to pass it over to Joel so he can talk about the anatomy of Snap plugins.
Thanks, Matt. We're going to go briefly through what loading a plugin is like, starting a task, what it means, and then I'll pivot to do some more demonstrations. So we'll go through these slides pretty quickly here. Loading a plugin, Snap starts the plugin. It negotiates over standard out. It is going to get back the listen address, which it then makes an RPC call and gets the config policy, and then the metrics it's going to collect. So that updates the catalog, which we'll see in a minute. And then it stops that plugin. So you can load 50 plugins. It's just going to update the catalog, essentially, get the configuration, and then stop those. When you start a task, the plugins that are leveraged in the task are going to be started if they need to be started. Or depending on how you wrote the plugin, and we'll get into more detail on this, there's some nuance around routing to plugins, how many instances of the plugins are needed, et cetera. So again, the subscriptions when the task is started drives the routing and concurrency. Stopping a task is going to adjust that subscription level and potentially stop plugins. The plugin metadata is one of the attributes that you're going to use when creating a plugin. And we'll dive into some code and look at the Python plugin lib and a brief introduction to how you can use this. But it's pretty straightforward. Again, it's communicated over standard out when Snap starts the plugin. And essentially, this is what it looks like. You're telling it the name of the plugin, the version, the RPC type and version are related to the data format that's going across. So we're using gRPC primarily. And the RPC version is going to be the proto version that we're using. And then the rest of it, so like the cache TTL, pretty straightforward. Routing strategy. There's different types of routing strategies. The default is going to be a round robin. You can have a config-based strategy that would be really good for a publisher where you have a configuration that connection string might be shared between multiple tasks, but you have another task that's writing to a different Influx database or a different Graphite database, et cetera. And so some of the fields that you're going to find in the meta here. The RPC service definitions for a collector, you have the collect metrics, the get metric types. Ping, kill are both implemented by the standard library, so you don't need to actually implement those, though you could override them if you needed to. The get config policy you'll provide an implementation to. So there's 3 methods on the collector that you'll provide an implementation to, and we'll see those in just a minute. On the processor, there's going to be 2, the process and the config policy. The ping and kill are, again, implemented by the plugin libs. And the same for the publisher. Just the publish and the get config policy is what you would implement. And like mentioned, the routing strategies that are implemented today are the LRU sticky-based and config-based. So sticky meaning that it's going to be a one-to-one relationship between the plugin and the task. Concurrency count is something that is going to be set to 4 by default, and you could increase it or reduce it. Just telling you how many instances that you want per number of tasks that could be hitting that plugin. Exclusive is going to give you your singleton approach, so only one instance of this plugin could ever or should ever be running. And cache TTL set at 500 milliseconds by default just protects you from creating a task that's going to overrun your collector. So as a collector implementer, you might know that I'm going to collect this data and it's not going to change over a minute. So you could set your cache TTL to a minute, and then someone that just didn't maybe understand what they were doing could set a 1-second task, but the framework won't even dispatch to the plugin. All right. So for starting with, we have the gRPC, which is the plugin lib's current implementation for communicating, and originally it was Go RPC, which we will continue to support through 1.0. So the plugins that had originally been created will continue to support those, but moving forward it's protobufs and gRPC, and because of the availability of the SDK, we've written plugin lib so far in these languages here. All right. So the first thing we're going to look at is a Python diamond collector. So it's going to wrap around diamond, and then I'll come back to this. I started up in GCE 25 nodes, and I'm going to demonstrate tribe, which is a clustering mechanism to help manage multiple Snap instances. My goodness. All right, so in this example, we're going to look at a diamond. Is anybody familiar with diamond? Okay. For those of you that aren't, it's a collector written in Python, and what we're going to demonstrate here is wrapping that collector with Snap. So giving you all the features of Snap as far as being able to manage the plugins and the tasks. In this case here, we're looking at the config that I'm going to start Snap with, and we're defining where the where the diamond collectors are with the collector's path on line 8. And then on line 9, the config that's being passed into Snap. So this is the exact same config that you would pass into Diamond. So if you're familiar with Diamond, you would be setting like a diamond.cfg file, and it would provide these same exact arguments. In this case here, I'm doing a ping collector because it actually had some arguments I need to pass into it, and then just basic system collection. Looking at the implementation, we're going to take a look at first the update catalog, starting on line 78. And on line 80 here, which I'm going to just describe and not jump into any detail, this is essentially just looking at the config that was passed in and dynamically loading those Python modules so that on line 83 here, when we do the collect, that collect is actually against the diamond code, right? So I didn't modify any of their code. I just do the collect. In that init, I also add a handler, a snap handler, and I'll briefly show that at the top. But that's how we essentially use what they had already exposed to just tap into it. And then there's a get metrics call, and in that get metrics call is where we turn it into a snap metric and return it. And then the config policies, you can see these are the exact same things that I provided in that config we looked at. That was the collector's path, where those modules exist, and then the actual diamond plugins that I want to load. The collect is very similar. It's going to take the request coming in and then dispatch on the collect call on line 70 to those diamond plugins. It's going to ensure that the results that I get back are these the metrics that they requested. That's what's going on between 71 and 74. And then we simply return those metrics to the framework. So let's go ahead and take a look at it, see what it looks like when we launch it. Okay, actually one other thing I want to describe. So I could load the snapdiamond.py here because I have my Python path set correctly. But generally what you're going to want to do in like a Ruby plugin or a Python plugin is package your virtual environment so you have all your dependencies included. And so there's a script that I added here for packaging. Our package format that works, you could actually create a totally different package format, but we just leverage the ACI. And so right now it's building an ACI image. In that image, it stuffed the virtual environment, it stuffed this code, and it set the execute path. Again, using a Go plugin, right, it's a self-executable plugin, and you just run it, and it's going to print standard out, allows the framework to communicate with it. This is going to happen the same way, except the framework understands when it sees it that it's an ACI, it explodes it onto the disk, and it executes like it normally would. So in this case here, I'm going to do a SnapTell plugin. Okay, and then here are all the metrics that are being exposed by the Diamond plugin that I loaded. Creating a task. So now it actually started the plugin. So I can see SnapTell started the Snap Python plugin. And with terrible formatting because of the width and everything, you can see the things are being collected. All right. So I'm going to move on to Tribe now. Tribe is a gossip-based protocol that is going to allow us to create an agreement. So you act on Snap the same way that you normally would, but what you're first going to do is going to say, I'm going to create an agreement, I'm going to add all these nodes to it. So they're going to agree to load the same plugins, load the same tasks. So I had 25 nodes, and I added them all to the agreement, and I started to do administration across one of them, loading plugins, starting task. It will automatically happen on the other ones. Okay, so doing a member list tells me the global membership that this node understands. So it knows about all of these other nodes. Now I need to add it to the agreement. So I created a couple scripts here just to help me out. In this one here, you can see that I'm looping over the member list, and then I'm doing a SnapTell agreement join. I called the agreement main and the member. And so right now, if I do an agreement list, by the way, just so you can see that, I had prepped this by starting Snap in Tribe mode and creating this agreement called main, which has itself as the only member, and there are no plugins or tasks loaded. So I joined the agreement, and I'm going to take a look at that agreement list. Now I can see 26 members. That's perfect. Let's load some plugins. So again, another little script just so we can see what's going on. I'm going to loop around those members again, and then on each one of the members, I'm going to call SnapTell plugin list. And you can note that I'm setting the Snap URL, so I'm actually doing it to each one of those 25 members. And I just want to ensure that everybody has the same plugins loaded. They do. They all have 3. And so I was on one node, added 3 plugins, and that automatically got pushed out to the other nodes. And then the last thing that we'll do is go ahead and create a task. Wait for just a second, and I think it'll be good. And we see that it's running across all of those nodes. Forgot what kind of window I was in, so you can see it. It's so bad, the wrap. But what I'm looking at is the right justified column, and I can see the number of times it's hit, and it's hitting on all of the systems. And here we are graphing network packet sent, just as something trivial to to Graph. We'll go ahead and stop the task. And it'll get stopped across those 25 nodes. And then so I don't forget, I'm going to resize the instance group back down to 0. All right, so that concludes my demo.
Plug back in?
Yep.
All right. Cool. All right. Well, that was awesome. Seeing Tribe, I think Tribe is one of those really special features of Snap. It's in beta as of 1.0 because gossip and distributed systems is hard. And we need more people looking at it and testing those edge cases because edge cases at scale are everyday events. But it's absolutely fantastic to see it up and running on the cloud platform. So just to review a little bit of what we talked about, Snap is a simple plugin-based architecture designed to be part of your monitoring solution that has 3 types of plugins: collectors, processors, and publishers. We didn't get into the processors because that's a little above my intelligence level. We have a team of statisticians that have been digging into different filtering mechanisms that you might put on statistics and decorations of information. I bet Jacob's going to get into it a little bit when he writes a plugin this afternoon if you want to learn more about the development side of this. But just know that there are 3 pieces of the puzzle that the middle one's optional, but collecting and publishing are the main events. We have, as of Snap 1.0, we've got a large number of plugins, mostly written in Go, and then client libraries for C++ and Python as well. And you can see, as of Joel's example, that you can wrap existing tools like Diamond and get that working with Snap in a pretty small amount of time. And really, Snap 1.0, as any announcement of a label on GitHub, is just the beginning of something. We're really excited to have a huge community of people that are starting to influence the project. We're looking to grow the influence on our maintainers by having people outside of Intel be crucial in that. And we think the more you build plugins for your use cases, the more valuable the overall framework gets. So looking forward to having more people get involved. So with that, I think we can start going for some questions. The question was, do we have any Kubernetes support or plugins for it?
There's a lot of activity on Kubernetes right now in the monitoring pipeline. We had a POC demonstrated at one of the community sync-ups where we integrated into the existing Heapster pipeline Snap. And the way that it was done is Snap would load a plugin that would essentially replace what CAdvisor was providing. And then our publisher started a port that Heapster was able to pull off of, and then we could demonstrate the HPA. So that was the ultimate point, right, is I want to be able to horizontally scale and have the CAdvisor statistics in there. The upshot for us is that when you go and define the YAML for your pod, the annotations that we expect to be able to provide in the future is going to be able to give you that APM characteristic so that you can start to scale on loans per second or whatever your business metric is, be able to define those things declaratively, and it would load the plugins on that Snap instance potentially running adjacent to those running pods.
Yeah, and a couple other things to note that we have a team internally that runs our whole test infrastructure, which was a really important part for us reaching the 1.0 tag, is that we test the hell out of Snap. So we're running on top of Kubernetes, and the way that's monitored is through Snap. So we've got a floating pod inside that configuration that monitors all the API-driven technologies in there. And then on each node that's running Kubernetes, we have a Snap instance as well. So if you're looking for any sort of reference architecture, we haven't written anything down on that because it's still early days. And with Kubernetes monitoring pipeline in flight and them actively trying to change that, we're hoping to become a first-class citizen of that through the plugin architecture there. But to date, we play nicely with CAdvisor. We can query CAdvisor, or you can use it as a separate tool that then will publish to other sources.
Thank you.
Yeah. I love the question of the balance of power versus ease of use. It's a constant tension in any sort of open source project. What I really love about Telegraph and part of CollectD's design is that you compile the plugins that you want into that one binary and then distribute it, which makes it really easy to know what you're collecting and what you're publishing to and organizing that in your head. And we made the conscious choice of decoupling those things for flexibility, but it comes at the cost of getting up and running. So a couple different initiatives going on. I could still say there's plenty of room for improvement. So I totally agree with your first experience there. Since then, we've been packaging each individual plugin and creating some scripts in a repository so that you can download them pretty easy and see great use cases. So if you go to each of the different plugins, there's an examples folder, and in the examples folder, it has example task manifests and advice on how to get that up and running from collector to publisher. And so that's one step, but I think that's a smaller one. The much bigger one is what I love that Grafana Labs is doing, which is using their plugin architecture to have a one-click deployment type configuration with Snap, where you actually, you say what you want to collect and where you're going to publish to, you install the plugin in there, and then it will actually deploy Snap, it'll download the correct plugins, it will load the task manifest, and you'll be having that data stream into Grafana. So I'd say we're at the early stages of making that a one-click and go experience, and we need a lot of improvement for the initial POC stage at this point. But I hope you reached out to us we've got a public Slack channel and a really active community on there of people helping it get up and running. And if I can grab your card after, we love working with people and hand-holding, so we're still getting that feedback and improving that experience. Joel, anything you want to add to balance of flexibility versus ease of use?
No, it is definitely a balance. So, two things that I wanted to mention. So going forward, our focus right now is going to be trying to figure out what people like, what they don't like. But beyond that, we know that we're going to be adding some capabilities around embedding the plugins so that you wouldn't necessarily have to deploy in the same way that I just showed, right? So maybe you just start snapd and you know that across your HPC environment, you're going to be running these type of things. So you kind of have them built in, right? And it's easier then to also profile and do a lot of, make sure that the performance is right there for you. And also being able to load remote plugins, meaning something that might be running on an IoT device on the edge. It's not going to have this starting up and backing off. It's just going to expose an interface, and you need to be able to say, here, I'm going to talk to this on this port. And being able to essentially load that remote plugin is kind of an important characteristic. One of the features that we didn't talk about was in that declarative model of I want to go process and publish. I want to use this processor and this publisher. We were doing it node local. You could go remote. So those use cases where you have a bastion host and that's the only one where you can talk to your database is a perfect example. Or in the processing where FPGAs are going to start to become common on package, there's going to be workloads that for doing certain types of processing, you could have your workflow go dispatch to a group of nodes that are processing the metrics and then sending them back to another host to be published. So really, just trying to flesh out a lot of those details, make that experience a lot easier to use while not dumbing it down to the point where it becomes kind of useless, right?
Okay, I think that's all the time we have. Thank you so much, both Matthew and Joel.